This video provides an overview and demonstration of a permanent magnet AC generator designed by myself, Brandon Parrish, and Peter Newell. Initially, our design focused on a homopolar generator to generate direct current by passing a non-rotating magnetic field through a rotating aluminum disc. However, this design produced minimal voltage on the magnitude of 1 to 5 millivolts. Because of this low magnitude of voltage, we decided to pursue an alternate design which would greatly increase the magnitude of voltage produced. If you look on the right, you'll see that iterations 2 and 3 utilize a rotational system for the magnets, which are placed on the central shaft and are surrounded by either one magnetic coil or two magnetic coils, respectively, for iterations 2 and 3. The second iteration of our design utilized a rotating magnetic field to induce alternating current in a stationary coil due to the relative motion between the rotating magnets and the stationary coil. This resulted in a larger magnitude of induced voltage when compared to the first iteration of our design. Because of these substantial improvements, we decided that the design could benefit from having an additional stationary coil of magnet wire added, which can be seen in iteration 3 in the next slide. Furthermore, the maximum voltage that could be reached for this design, or the peak voltage, was roughly 0.5 volts. However, this was very inconsistent, and overall we were able to reach 0.4 volts on average. Again, this utilized just a singular magnetic wire coil, as well as just one set of gears when compared to the third iteration, which utilized multiple gears to increase the amount of torque that was transferred from the hand crankshaft to the final central shaft. During testing, the maximum voltage we were able to reach consistently with the third design iteration was roughly 4 volts. However, we were able to reach peaks at around 5 volts, but these were much more inconsistent throughout our testing. Additionally, after testing both one stationary coil in the second iteration of our design and two stationary coils in this final iteration, we believe that the design could be improved even more with the addition of more coils in an alternate configuration. However, due to our original design of the generator's base plate and the original size of the coils we used, there would need to be substantial design changes for both the coils and the base plate for them to be added to the generator to increase the amount of voltage that would be induced. If you look on the left, you can see that our theoretical values match our experimental values very closely, both in trend and in magnitude, with a linear relationship between RPM and voltage being observed for both.